Hello again to one of these kind of grade 3 to grade 9 walkthrough questions. So again, this topic starts at grade 3, so foundation. It goes all the way up to grade 9, super hard, very difficult and challenging questions. Ratios tends to be something that everyone hates, which is completely understandable. But all you need to know with ratios is that they show multiplicative relationships, right? So if I say, let's say I have 2 times the number of blue counters as red counters, I can write that in a ratio of blue to red as 2 to 1. Because if you have a look, it tells me that blue is 2 times the red ones, right? Which is also the same as doing like 4 to 2. It's still 2 times the amount, okay? Using this fact is actually how you solve every single ratio question, okay, and how you understand it. All it's showing you is multiplicative relationships. Now, you may have seen ones that are like, for example, 2 to 3. So what does that mean? Well, in this case, the reason why they've done that is because ratios can only be integers in most cases, right? We tend to give them as integers. But what this actually means, if we divide both sides by 2, is that b, or in this case r, is 3 over 2 times bigger than b. That's all it means, okay? Anyways, that may be a bit nebulous at the moment, so let's start with the grade 3 stuff. And again, I'd recommend you watching the whole thing, even if you're confident, just so you can understand where we're coming from. So it says write down the ratio of 220 kilograms to 5 kilograms in its simplest form. So again, all we're going to do is 220, and the word 2 is just represented by a colon when it comes to ratios. Now, simplest form means we have to divide it by the biggest kind of common factor. So the biggest number that goes into 220 and 5, which is of course 5. 220 divided by 5, so I divide by 10, which is 22, and double it, which gives me 44 to 1. Okay. Then here, write the ratio 32 to 24 in its simplest form. So again, what I normally do is I just keep dividing by 2 until I can't anymore. And bear in mind, you don't actually need to write the divide by 2s, you can just do it. So 16 to 12, 8 to 6, 4 to 3, and then I can't go any further. So I just keep halving it until I can't anymore, and then I think about kind of what other numbers it could be. Now, as I said before, the ratios show multiplicative relationships, right? And it says here, a ninth of the people in a class are left-handed. Now, if we think about what this means for a second, that means that, so we have 1/9 are left-handed. Which of course means 8/9 are right-handed. Now the other way to think about this, right, is that if 1/9 of them are left-handed, then what would the ratio be? Well, the ratio would have to be that the right-handed people are 9 times bigger than the left-handed people, right? Or 8 times bigger in this case. So here's how you would translate this into a ratio. All you need to do, and if we're doing left to right, which is what it's saying in this question, all we do is we take the top number, because that's the number that's associated with left, right? Left-handed is 1, so we're going to take the 1 and put it there. Okay. Then all you do is you take that number away from 9. So in this case, it would be 1 to 8. Okay. Which actually does give me 8 over 9 right-handed people as well, because how do I get from a ratio to a fraction? I take the number I'm interested in, so the 8, and put it on top, so that's where the 8 comes from. Then I add on the other parts of the ratio over 9. Okay, so you should be able to go back and forth from this, and we're going to do some more examples of this, but I just wanted to show you. So again, to go from a ratio to a fraction, you take the number you're interested in, so in this case, if it's right-handed people, we take the 8 and put it on top. We put it over, and the denominator is just the sum of all the parts of the ratio, so 8 plus 1, which is 9. To go backwards, all I did was, it says 1/9 are left-handed, right? So what I've done is I've taken the 1, the numerator, and put it underneath the L. Then I think 1 plus what gives me 9? Well, it gives me 8. So we have to do. Again, we do have some more kind of examples of this, and we're going to use it quite a bit, so should be okay. This is write the ratio of 15 to 35 in its simplest form, so divide both by 5. That gives me 3 to 7, which can't be simplified any further, so there you go, all done. There are red shapes and blue shapes in a box. 2/3 of the shapes are red. Write the ratio of red to blue shapes. Okay, so here it says 2/3 are red. By the way, the link to these questions is obviously in the description, so you can either follow along or you can watch this video afterwards as a sort of mark scheme. Anything that you would like to do in terms of that. So then, red to blue. Remember, we take the number we're interested in, the 2, and put it under the red because it says 2/3 are red. If it said 2/3 are blue, the 2 would go under the blue. And then what do I add to 2 to give me 3? 1. That's it. Okay? Here we go. So in a bag there are blue sweets, red sweets and yellow sweets. The number of blue sweets is 4 times the number of yellow sweets. The number of red sweets is half the number of yellow sweets. Find the percentage of sweets in the bag that are yellow. So from here we're going to use a few different pieces of ratios. Okay, so this is getting into grade 4 territory. What we're going to be using, and so that means it can come from foundation by the way, is the multiplicative relationship thing that I said. And we're also going to be combining ratios. So it says the blue sweets is 4 times the yellow sweets. That means B is equal to 4 times yellow, right? Number of blue sweets is 4 times, so that's where the 4 comes from, the yellow sweet. So B is equal to 4y. So the ratio of B to y, well, B is 4 times bigger than y. This step here confuses even grade 9 students, okay? So hopefully you grade 9 people haven't skipped ahead, okay? But you've asked me why does the number switch round? It doesn't really switch round per se. All it's saying is if this first line saying B is equal to 4 times more than y, which means the 4 should go under the blue because it's 4 times bigger, right? Cool. The number of red sweets is half the number of yellow sweets. So here we have red is equal to y over 2. So what I'm going to do is times both sides by 2, so I get 2r equals y, which means the ratio of r to y, well, y is 2 times bigger than r, so I put the 2 under the y and I put the 1 elsewhere. So now I have these 2 separate ratios, right? And in general, we don't want 2 separate ratios, we want to combine the ratios. Because it says here, find the percentage of sweets in the bag that are yellow. I can't do that when I have 2 separate ratios. How do you combine the ratios? It's actually really, really easy. You look for the letter that's in common, okay? If you don't have a letter that's in common, we're going to come up to that a bit later, but that's about grade 6. That's actually not something you expect to do in foundation, okay? It's about a grade 6 kind of topic. So for now, there will always be a letter that's the same. If there isn't, again, that's a grade 6 topic. We'll come up to that in 1 second, okay? Can you see that y is in both ratios? If we look at the number associated with it, we have 1 and we have 2. We need to make them the same, okay? So we're trying to make these 2 things the same. Now, in general, we can't really divide because there's fractions and stuff. So I'm going to times this first one by 2. So if I times this whole thing by 2, we get 8 to 2. And just like in fractions and just like in algebra, whatever you do to one side of a ratio, you have to do to the other. So now we have that the y's are identical to each other. So now we can actually write this as one big ratio. B to y to r. B is 8, y is 2, r is 1. So it's saying find the percentage of the sweets in the bag that are yellow. So the way I would do that is I'd find what fraction of them are yellow. So yellow equals, well, the number associated with yellow is a 2. And then we have, in total, how much? We have 8 plus 2, which is 10, plus 1, which is 11. So 2 over 11. And then all you need to do is times that by 100. If the fraction was slightly nicer, then I would say do this without a calculator. But because the fraction's a bit ugly, we're going to do it with a calculator. Okay? So times 100. Yeah, so 18%. Just like that. Okay? Perfect. Now we come on to sharing in a ratio. Again, this is a grade 4/5 topic. The reason why I say 4/5 is this particular question is grade 4. There is a grade 5 variant which is coming up, and that again, that means it comes up in foundation and higher. So Will and Ollie share £80 in the ratio of 3 to 2. Work out how much each of them get. So there are so many ways to do this. Okay, there is something called a bar model which you can do. There's just all sorts of stuff that you can do. Okay, so the way I'm going to do it is I'm going to do it as a parts thing. And the reason why is because a lot of the later questions that are in higher grades are most easily explained using parts. If I look here, this ratio here, can you see in total I have 3 plus 2, 5 parts, right? So this £80 is going to be divided into 5 separate parts. So it'd be useful for me to know how much one part is worth. Again, if you have a different way of doing that, that is completely fine, but I find this to be the best method when it comes to doing the later questions. So it means one part is worth £16. Okay? So, how much does Will get? Well, how many parts does Will get? He gets 3 parts. So he gets 3 times 16, which is £48. And Ollie should just get the rest, which is £32, but to show you that this works anyway, he gets 2 parts, so that's 2 times 16, which is equal to £32 anyway. That is the way I do it, and I would recommend you do it if you're very unsure, because it will help you with some of the later questions as well. So Molly, Paige and Demi share 42 sweets in the ratio of 3 to 2 to 1. Work out the number of sweets that each of them receives. So again, add up all of the parts of the ratio, 3 plus 2 plus 1. That's 6 parts in total. So again, we're going to work out how much one part is worth. Okay, by doing 42 divided by 6, which of course is equal to 7. Okay, so if we just start from the last one, go forward, we have Demi. She gets 1 part, right, because she's the one on the end. 1 times 7 is equal to 7 sweets. We have Paige. She gets 2 parts, right, from over here. So that's 2 times 7, 14. And lastly, we have Molly. She gets 3 parts, or the rest, however you want to do it. So they all get 21 sweets. That's how you would do it. And if you notice, all 3 of these numbers add up to 42, because of course if we're sharing 42 sweets, it doesn't make sense that we get 40 sweets or 50 sweets or something like that, right? Okay. Hopefully this is making a bit of sense. Again, I will say that with ratios, your problem, if you're struggling with these, is most likely that they were never explained to you properly. Okay, because other than that, they do become a bit easier, a bit simpler. So hopefully you're getting that understanding now, okay? But again, practice is what you want to do. Now here is actually very similar to some of the vector questions we were doing. Do you remember when they would say like A to B, or A to B to B to C is equal to 3 to 2 or something like that? This is very similar to that actually. So ABC is a straight line. The length of BC is 3 times the length of AB. So that means BC to AB is 3 to 1, right? You can even write it here if you want, 3 to 1. Now the total length, please excuse the terrible lines, is 80 meters. We need to work out the length of BC. Okay, so again, what I'm going to do is there are 2 ways to do this, right? This is the same as sharing in a fraction, right? So in this case, we have 4 parts in total. So 1 part is equal to 80 over 4, 20 meters. So that means BC is just equal to 3 times 20, which is 60 meters. Okay, that's one way to do it. That's completely fine. However, and this is a bit of a however, there's another way to do this. Okay, so I've been showing you this one particular way, and this is the way I'd recommend doing it. But there are other ways available. So if you're not too sure about this way, you're more than welcome to look up another one or leave a comment and I'll show you another method. But in my opinion, this is a very simple, basic way of doing things. Okay, which is what we want. Simple in maths is better. Okay, you just want to get the marks and that's it. Here's where things get a bit more interesting. This is where we start stepping into grade 6 territory. Carly and James share some money in the ratio of 5 to 3. Carly gets £70 more than James. Work out how much money James gets. If you notice, they haven't given me the total amount of money. So, okay, well, when in doubt, just kind of work out the exact same thing that you did before. So 5 plus 3 is equal to 8 parts, right? Now, of course, the next step will be to take the total amount of money and divide it by 8, but I don't have the total. Okay, that kind of sucks. Let's look at the next piece of information, though. Carly gets £70 more than James. That's interesting, right? £70 more than, right? Now, if we have a look at the number of parts, Carly is 5, James is 3. She gets £70 more than James, and she also gets 2 parts more than James, right? Because 5 is 2 bigger than 3. So in other words, 2 parts is equal to £70. Right? £70 more than James, and she also has 2 parts more than James. So those 2 parts must be worth £70. So 1 part is equal to half of 70, which is £35. So how much money does James get? Well, James, how many parts does he have? Well, he has 3 parts. So 3 times 35, which is 105. Yeah, £105. And that's it. Okay. So it is more tricky technically, but if you kind of think really carefully and logically, right, and stay calm, hopefully you could make that connection potentially, maybe, possibly. I mean, don't get me wrong, I understand that GCSE maths, it kind of beats the creativity out of you, and you kind of just learn methods and things like that. But, you know, hopefully you can see kind of where it's coming from here. Now, here's another kind of question. Jerry and Mick share some money in the ratio 2 to 3. Mick gets £900. Work out how much money Jerry gets. Okay, well, once again, Mickey's getting £900 and he has 3 parts. So 3 parts must equal £900, which means 1 part is equal to £300. 900 divided by 3. Okay? And it says work out how much money Jerry gets. Well, Jerry, how many parts does he have? Well, he has 2 parts, right? So 2 times 300, which equals £600. Not too bad, right? Once you understand ratios, they do become a lot easier. I mean, that's the same with anything in maths, but yeah, I feel like the biggest problem with ratios is a lot of people just don't understand them because you weren't taught them properly, which is not really your fault. Okay, now we're going to come on to the next kind of part of the question, which I personally really, really enjoy. Now, these questions can be worth about 3 marks, and again, there are a bunch of ways to do it. And yeah, bunch of ways to do it. So again, if you're not kind of doing it the same way I'm doing it, that is totally and utterly fine. What it says here is that Bob wants to make orange paint. He needs to mix red, yellow and white in this ratio. So what I'm going to do is I'm just going to write red to yellow to white again. And I always rewrite the ratio in every single question I do, just because, you know, it's nice. And Bob wants to make 750 millilitres of orange paint. He has this much paint. Does he have enough? So there are a few different ways you can do this. What you can do is you can do the same method we did before, right? Where we add up the number of parts and just work out if he has enough. So what I mean by that is the total number of parts here, which is 5 plus 4 plus 1, is equal to 10 parts, right? Now he wants to make 750 millilitres. So what we can look at this is that at the moment we only have 10 millilitres. Okay? So what I want to do is make the number of parts equal to this number here. Okay? And again, the reason why I'm doing that is when you simplify a ratio, it gives you the most basic proportion, right? So this is saying I need 5 millilitres of red paint for every 4 millilitres of yellow paint for every 1 millilitre of white paint. Okay? So basically that tells me that every 10 millilitres needs 5 millilitres of red, 4 millilitres of yellow, 1 millilitre of white. That's all that's telling me. Now if I want to make 750 millilitres, I need to make 10 into 750. So how can I do that? Well, if I work out 750 divided by 10, that's 75. So if I times this whole thing by 75, I will get the exact amount of each paint that I need, and I can literally just look and see if I have enough paint. That's it. Okay? Now, of course, the timesing by 75 is a bit tricky, but I know we can do a few of these already. 1 times 75 is going to be 75 millilitres for the white paint. So if he needs 75 milliliters of the white paint, if you look, he actually has enough because he has 200 milliliters of white paint, right? The only time we're going to be concerned is if the number in the ratio is bigger than the number up here. If it's less than, that's completely fine, right? Because he has enough. 4 times 75, well, 75 times 2 is 150. Times it by 2 again would give me 300. And if you have a look, the number is actually the same as the number of white paint he has. So, okay, that's really good, right? Because it's the same, he has enough. Now, 75 times 5, well, I think we're just going to have to use good old-fashioned column method. 5 times 5 is 25. 5 times 7 is 35. Add the 2 is 7 and 3. So, in short, if you wanted to make 750 milliliters of orange paint, he would need 375 milliliters of red, which he has. He needs 300 milliliters of yellow, which he has, and 75 milliliters of white, which he has more of. The only time we should be worried is if the number in the question is smaller than the number we have here, in which case he can't. So does he have enough? The answer is absolutely yes. Okay. The other way to do it, which is where you, again, if you're fine with this method, close your ears for about 10 seconds. The other method where you make a fraction and you work out the fraction of each amount that you need, in my opinion, that takes a lot longer. This did not take me very long at all. Okay, so uncover your ears, although I'm not sure exactly how you're going to be able to hear that if you're covering them, but whatever. We have, okay, this is one of the questions where, again, I get asked this all the time. It's grade 6 to 7, maybe 8, depending on how tricky they make it. Dogs to cats is 5 to 3, so again, all I'm going to do is write out the information. Fish to dogs is 6 to 1. What am I doing? Fish to dogs. Actually, never mind. This is not as hard as I thought it was. I'm thinking of a different question. My bad. It says work out the ratio of cats to fish. So all you need to do here is make these ratios the same. Okay? Now again, we have dogs similar in both. So if you remember, we need to make the numbers the same. So I'm going to times this one by 5. That gives me 30 to 5. Make it all one ratio. So if we just do it as fish to dogs to cats, the fish is 30, the dogs is 5, the cats is 3. So the ratio of cats to fish is just going to be 3 to 30. And if we simplify, we can divide them both by 3. It's 1 to 10. Okay? I thought that was a different question, my bad. Okay. A to B to B to C. Again, very similar. We want to make the letter that's the same. So in this case, B is in both of them. We want to make them the same. So we want to make 5 and 3 the same. So what I would do is times this one by 3, this one by 5. Just times them by each other would be the best way to do it. Which means A to B is now 3 times 4, which is 12. 5 times 3, which is 15. And then we have B to C, which is 15 to 10. So A to B to C is 12 to 15 to 10. It says give your answer in its simplest form, but can we simplify this? So we could divide the first two by 3, but that's it. Divide it by 5, no. So that should be the simplest form. Nice and easy. Okay. This is the question where it gets tricky. My bad. Andy and Bruce share some sweets in the ratio of 9 to 4. So okay. And Carla and David share the same amounts of sweets in the ratio of 5 to 2. Okay? And what we need to do is work out the ratio of A to B to C to D. Now, what is the problem that you notice straight away? I'll give you a second. Well, you might notice that there is no common letter, which is a bit of a bummer. Okay? Now, it does say they share the same amount of sweets, so that's nice, right? But we can't just write all this ratio in one long line because, for all I know, they've simplified the ratios. That's what this part here means, by the way. Andy gets A, Bruce gets B, Carla gets C, David gets D. What they're saying is I can't say that this is the actual amount they get because they could have simplified the ratio. So this could actually be 10 to 4 or 20 to 8 or anything like that. So how do we make them the same when there's different letters, there's nothing in common? And this is a question, not the last one, but this is the question that I get asked quite a lot, okay? And it's not that tricky, But again, if you've never been taught it, you've never been shown it, it's going to be a bit of a mind-blown situation, okay? So here's what you do if the letters are not common between your two ratios. If I have a look, I'm going to add up these two and I'll say that there's 13 parts here, right? And there's 7 parts here. Okay. Now remember, they're sharing the same amount of sweets. So realistically, these parts should be the same, right? Because think about it. The number of parts need to be the same because I'm sharing the same number of sweets. So all I want to do is make the number of parts the same for both ratios. Okay? So again, we're not making the letter the same, we're making the number of parts. The best way to do that is to times them by each other. So I'm going to times A to B by 7 and times C to D by 13. That will give me, so 9 times 7 is 63. 4 times 7 is 28. 5 times 13 would be 65, yeah. 13 times 2 is 26, okay? Now, because the number of parts is the same, that means that we now have the unsimplified version of the ratio. So now we can write A to B to C to D just by subbing in the numbers. So A was associated with 63, B is 28, C is 65, D is 26. And we don't need to simplify because that kind of defeats the purpose of what we're doing, okay? I hope that makes sense. I'm hoping. But essentially, all we're trying to do here is make the number of parts the same because that will give us the unsimplified ratios, okay? Which means we can then just write them all out at once. And if you notice, both of these have the same totals, which means we can combine them, okay? Okay, and then on to this question, which is from Edexcel, but I think quite a few of you would have seen this in your mocks, at least I did. I mean, I didn't sit the mocks, but I handed it out. This ratio question, it's only 3 marks, by the way. 3-mark ratio question really screwed over a lot of people, okay? And we're going to kind of see why right now. So, how do we approach this? We have each card has a black circle or a white circle, or a black triangle or a white triangle. And it's saying that the black to white shapes is 3 to 5, and circle to triangle is 2 to 7. So express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. And what some people did is they just said it's 3 over 7. What we want to do is very similar to this part, is we kind of want to combine the ratios. So if I just call it black to white, that's 3 to 5, right? And let's do circle to triangle, that's 2 to 7. Okay. In total, we have 8 parts here, and we have 9 parts here. Now, the reason why we want to combine them is because I don't actually know how many black shapes there are, how many white shapes, how many circles, how many triangles there were. Another thing some people did, by the way, is they said, okay, it's going to be 2, because there's 2 black shapes, over 2 triangles. So 2 over 2, which is 1. Which, of course, is not correct, right? These are examples. It is a bit misleading, though, right? There are 4 types of cards. That doesn't mean there are only 4 cards. There could be 400 cards, or 4,000, or 4 million, for all I know. 16 million, who knows? So that's why we need to do this, okay? Because then we can work out the total number of black and white cards, total number of circle and triangle cards. Okay? So, we need to make them the same. So times this first one by 9, times the second one by 8. So we have here 3 times 9, which is 27. 5 times 9, which is 45. 8 times 2, which is 16. 8 times 7, which is 56. Cool. Now it says we want the black shapes as a fraction of the triangular shapes. So how many black shapes do we have? So, I mean, if we write this all into one big ratio, if you'd like, it's not actually necessary to do this step, but, you know, may as well. We've earned this. Right? We have 27 black shapes, and remember, we want black as a fraction of triangle, so that's 27 over the fraction of triangles, sorry, the number of triangles, which is 56. Again, if you look at certain mark schemes, you might find kind of different methods and things like that. But keep in mind, and I really want to stress this, is the mark scheme doesn't show, it doesn't show the only method. It shows a method that you might expect, but in every single mark scheme, official mark scheme, with practice papers it can be a bit wonky, but in every actual mark scheme they say any valid method. And the part of the job of the examiner is to look at your method and say whether or not it's valid, right? Which is completely fine. Generally, if you get the right answer, they don't really care that much anyway. So, and not just that, it's not meant as an explanation. Mark schemes do not explain anything. So, this is the method I thought would be the easiest to explain to you guys. But that would be the end of it. So I hope you really enjoyed that. Again, I'd recommend you join the Discord because we do share kind of extra practice papers and things like that. Ones that are made by yours truly as well. And other than that, I hope your revision goes really well and have a great day.